Hello, Code Monkeys. Today, we actually got a request from an audience member who wanted to know why we use C. And I think this is actually going to be a pretty short video because there are three main reasons, and they're all fairly self evident, fairly easy to explain. And let's kick it right off. The first reason you would want to use C is because it makes you a better person and you get to tell everyone else about it. And we will call that moral authority. Even if nobody else recognizes your moral authority for using C, you will know. And you will have an unearned sense of superiority because you have written one program in the world's best programming language. Jokes aside, on to the real reasons. It works everywhere. This is actually often this is often referred to as code portability. It's actually the major problem that Java was trying to solve back when Java was the thing. Python and JavaScript too, to some extent. You put a lot of effort into writing some code, and it's fantastic. Runs great on the system you wrote it for. But what if you want to share it with your friend who's got a Macintosh? Well, in a lot of situations, you would just be kind of SOL for that. But C has the big advantage that almost every system I've ever run into has a C compiler. It has the C runtime libraries already installed. So you can sort of hit the ground running. Converting between Linux and Windows can get a little nutty just because the way you access system resources is different. There are different built-in libraries for that sort of thing. But those are fundamentally solvable problems, and if you don't actually need to move the same code between different systems, then the same coding principles will apply on both systems. It's just when you run into those specific situations, you'll have to change what you're doing. And the last reason we prefer C is because it is fast. I've actually spent a lot of time running around asking my friends in the computer industry why C is so fast, and the only consistent answer I've ever gotten has to do with what they call garbage collection, and that is a topic we're not going to get into today, but rest assured, if you write the same code in C and another language, Python, to choose a totally random example, you will be able to see the difference in real time. You can set up a test bench, or if you're doing, we worked a lot with the OpenGL graphics libraries, and just playing around with that, you can see with your eyes the fact that C is rendering faster. Now, that said, this is a bit overstated because the system that we have been working in for the rest of our tutorial videos, Alpine, does not actually have the usual C runtime and development libraries installed on it. It uses a very slightly different set called the Muscle library. This leads us to an interesting question. If you're using a different set of libraries, is it the same language? I would argue no. Once you get rid of the libraries, it's just the syntax you're copying, and the syntax alone does not define a language. But I do want to show just how easy it is to get C up and running on Alpine. It is actually a single command. So, if I switch on over to our Debian, Debian system over here, we are going to spin up a fresh Alpine container, and this should be fairly simple. I tried it a couple of times right before we started. We are going to docker run a container named Alp for Alpine. It's going to pull from the image Alpine latest. And we're going to give it a command to run, and that command is going to be tail-f/dev/null. I'm going to need to do a video on Docker in the future. Don't worry about what any of this means at this point if you're not up to speed. If you got a friend who understands any of this, it would be a good time to ask that friend for an explanation. But this is something we'll come back and revisit later. Did we? Okay, cool. No errors. Fantastic. Then we can get inside our container with a docker exec. The TI flags bind the input and the output to our current terminal. We're going to need the name of the container, and we're going to need what we want to execute. That's going to be sh. Believe that is correct there. And ta-da, we are in the container. If we ls, we got the usual things you see in /. Every system is slightly different, but most of these will be pretty similar across different Linuxes. All right, now we want to start writing fun C code. Let's make a little directory. C code. Hit ls again. There we go. We can see it super easily. To add stuff to Alpine, you use the handy-dandy command apk add, and the package that contains the fun, usual GNU C library is called libdev. Sorry, it's libc-dev, and it looks like it's going to install the muscle dev libraries along with it. Don't worry about that. And we're just going to apk add nano because we need a text editor. I guess we could do it all with echo given what we learned a couple videos ago, but I don't wanna. And now we got nano. cd C code. And we'll go ahead and touch hello.c, nano, hello.c. This is going to This thing does not like to play nice. Oh my, it's not going to play at all today. Well, we're flying with... Nope, there it was. Ah! Technology issues. They don't spare you just because you're a technology guy. Alright. We're going to include standard lib. Oh, I'm sorry, it's not standard lib, it's standard io.h. And we don't really need to do any of this. I can show you the short version. I think I've been pretty fastidious about using int for the return type of main, and I've been pretty fastidious about always including the two arguments. You don't need them if you're not going to use them, but for regularity, I like to make sure they're always there. Printf. Make sure I'm doing this right. It'd be kind of embarrassing not to. Hello, world of kitties. And if I'm right, I believe we come with GCC, so let's just GCC -ANSI for ANSI compliance. Don't technically need that either. -o hello.o. Input file is hello.c. Ah! Oh, I'm sorry, we're using Alpine. apk add GCC, I believe, is what we want. Alright, let's try that line again. And there it goes, /hello.o, no errors please, hello world of kitties. So, not necessarily the one line of CLI I thought it would be, but you got apk add. If we scroll up a little bit here, where did it go? apk add libc-dev to get the libraries, nano to get yourself an editor, and add GCC to get yourself the compiler. So 3 lines and you're up and running on Alpine. Alpine is a bit of an exception in the Linux world. If you're using any of the major Debian-based distributions, this stuff will already be there. I don't work as much with the Red Hat stuff, although it is quite popular, but I believe the same rules apply. It'll already have GCC and Nano, and the standard GNU C libraries installed. And I hope that answers the question why we use C, and the hidden extra question of how we use C in a situation where it's not necessarily available right off the get-go. Our little recap here is going to be because it makes you more awesome to do so, it runs everywhere, and it is faster. I don't have a good example of it running faster to show at this time, but we will come back around to that question in a later video. Thank you for watching, everybody. Hope you have a great day, and I hope you learned something.